In our previous video, we were looking at the plurality method of voting, and we talked about some of the flaws with it. And we're going to look at an example now that helps us to get a better visual of where the plurality method might not be the best choice. And then we're going to move on in to look at our second of our 4 preferential voting methods, which is the Borda Count method. So let's start with our example of burgers, pizza, and tie. We have 9 friends are going to dinner and they need to decide where they should meet, so they put it to a vote. And here is the preference schedule for their vote. Is there a majority winner? Well, there are 3 plus 2 plus 9 or 4 or 9 total voters, so a majority would be half, 4.5, rounded up to the nearest whole. So a majority would take 5 votes, and as you can see, tie received 3, pizza 2, and burgers 4. So no, there is not a majority winner. Who is the plurality winner in this case? Well, B, burgers, has the most with 4 votes, so it would be the plurality winner in this case. Now consider the restaurant that has the most last place votes, and you will see that again it is burgers. So even though burgers had the most first place votes, burgers also had the most last place votes. In fact, they had a majority of last place votes. So that brings up the question of, is it fair to only consider first choices? Because now we have 4 friends who are going to eat somewhere that have their first choice, but it's the 5 other friends' last choice. So is that the best choice in this case? And the answer is, most people would say no, there's got to be a better way, a better compromise. And so that's what we're going to be talking about in this next little section. Is there a way to find a compromise? So let's look at each of the candidates being compared head to head. In other words, burgers is going to be compared to just pizza. So we're eliminating tie for this comparison. Then we're going to have a comparison between burgers and tie, where we're eliminating pizza, and then pizza versus tie. So we're taking all 3 candidates and comparing them with each of the other candidates. So in the case of burgers versus pizza, we're going to get rid of tie. And you can see that pizza now gets 3 votes plus 2 votes, or 5 votes, and burgers gets 4. So pizza beat burgers in a head-to-head comparison. When we look at burgers versus tie, we see that tie now gets the 5 first place and burgers gets 4. So tie beat burgers in a head-to-head. And then when we look at pizza versus tie, we see that tie received 3 first place votes, pizza received 6, so pizza won. And so when we go back and look, we can see that burgers didn't beat any of the other candidates head to head. So even though the burgers won in the plurality method, the burgers didn't beat any of the other candidates head to head. In fact, pizza beat both of the other candidates in a head to head. So we might say that pizza is the better compromise candidate. Even though only 2 of the 9 friends chose pizza as their first place, notice that 7 of the 9 friends chose it as their second place, and nobody ranked it last. So it might be considered a good compromise candidate. When we talk about these comparisons and candidates that are capable of winning the head-to-head comparisons, we run into a new term called a Condorcet candidate. And the Condorcet candidate is any candidate who can beat every other candidate in a one-on-one or head-to-head comparison. So in our previous example, pizza was an example of a Condorcet candidate because pizza beat both burgers and tie in a head-to-head comparison. So in our burgers, pizza, and tie example, burgers was the plurality candidate, there was no majority candidate, and pizza was the Condorcet candidate. Majority candidates, because they have over half of the first place votes, are automatically Condorcet candidates. If a candidate has over half of the first place votes, then even if every other candidate were to receive all of the remaining votes, that majority candidate is still going to beat them head to head. So a majority candidate is automatically a Condorcet candidate. Plurality candidates might be Condorcet candidates, but they don't have to be. And there can be at most one Condorcet candidate, just like we saw with the majority candidates. Because a Condorcet candidate must beat every other candidate in a head-to-head comparison, it's only possible for there to be one, because you can't have two different candidates beating everybody else head-to-head. Now, we are going to study more about Condorcet candidates in our later sections in Unit 1, actually in our next assignment. But for now, what we want to do is go ahead and move into our next method, which is the Borda Count method. So the plurality method used the concept of first place votes to decide the winner. The Borda Count method is actually going to use a point system in order to determine the winner. So let's look again at the burgers, pizza, and tie election. And this time, let's reward each ranking with higher points, or higher rankings with higher points. So we'll give 3 points for each first place vote, we'll give 2 points for each second place vote, and we'll give 1 point for each third place vote. So rather than just taking into consideration the first place votes like we did with plurality, we're going to award points and look at all 3 places. So the winner will be the restaurant that ends up with the most overall points. So let's start with burgers. Burger received 4 first place votes times 3 points each. Burger did not have any second place votes, so it's 0 votes times 2 points each. And Burgers had 5 last place or third place votes, so it's 5 votes times 1 point. So 12 plus 0 plus 5 gives Burgers a total of 17 points. Now let's look at pizza. Pizza had 2 first place votes, so we do 2 first place votes times 3 points per vote, plus 7 second place votes, so 7 votes times 2 points per vote, plus 0 last place votes, so 0 times 1 point per vote, so 6 plus 14 plus 0, or a total of 20 points. And then last but not least, we'll look at tie. Tie had 3 first place votes, so 3 first place votes times 3 points per vote. 2 second place votes, so 2 second place votes times 2 points per vote. And 4 last place votes, so 4 votes times 1 point per vote, which gives us 9 plus 4 plus 4, or 17 points. So as you can see in this case, pizza received the most points, and therefore pizza would be the winner of the Borda Count method. So the Borda Count method is used to find the best compromise candidate, because it does take all voters' rankings into consideration, not just their first place vote. So the Borda Count method rewards higher rankings by awarding points based on each candidate's rankings in the ballots, and thus taking into account all rankings in the preference schedule. If N is the number of candidates, then award every first place vote with N points, every second place vote with N minus 1 points, third place with N minus 2, and so on until you get to last place, and the last place will always receive 1 point. If this method of awarding points is confusing, you can also think about it in reverse. Start by awarding 1 point for last place, and just increase the point value as you increase places all the way up till you get to the first place. And the Borda Count winner is the candidate with the highest point count. So let's look at our ABCD example using the Borda Count method. We have candidate A has 11 first place votes. So remember, we're going to start 4th place gets 1 point, 3rd place gets 2 points, 2nd place gets 3 points, and 1st place gets 4 points. So A has 11 first place votes, so 11 times 4 points per vote. A has 2 second place votes, so 2 votes times 3 points per vote. 8 third place, so 8 times 2, and 9 last place, so 9 times 1, or a total of 75 points. For candidate B, again, we could go through here. B has 8 first place, so 8 times 4. B has 8 plus 9, or 17 second place. 3 third place, and 2 last place, for a total of 91 points. We do the same thing for C. We'll notice that C has 9 first place, and C does not have any second place votes. So if it makes you happy to keep things lined up, you could put 0 times 3 right here, or you can just leave out the third or the second place section because there aren't any second place votes. So then C has 8 plus 2, or 10 third place, and 11 last place. And then D has 2 first place, 11 second place, 9 third place, and 8 last place. So in this case, who wins the election? Well, that would be candidate B with 91 points. And recall that the attorney was actually the plurality winner. So here's an example where we have 2 different winners depending on the type of election we are, or the type of voting method we are using with this election. So more about the Borda count. Let's consider an election with 3 candidates and 15 voters. How many points will first place, second place, and third place be worth? Well, remember, 3 candidates means there's 3 places. So last place is always worth 1 point. Second place would be worth 2, and then first place would be worth 3. So what is the maximum number of points a candidate could receive? Well, if a candidate received all first place votes, they would get 3 points per first place vote. And how many possible first place votes could they get? Well, if there are 15 voters, they could get 15 first place votes. So to find the maximum number of points, we're going to take the number of voters times the number of points for each first place vote, which gives us a total of 45 points. The least number of points a candidate could receive happens if the candidate receives all last place votes. So in that case, it would be 15 third place votes worth 1 point per vote for a total of 15 points. To find the number of Borda points on each ballot, remember that each ballot is going to have a first, second, and third place. So each ballot is going to give 3 points for first, 2 points for second, and 1 point for third, or a total of 6 points per ballot. So to find the total number of Borda points available for the election, we're going to take the total number of voters, in this case 15, times the total number of points per ballot or per voter, and multiply those together. So we get a total of 90 points available for this election. Or if we want to use a formula to find the total number of Borda points, we can simply take the number of voters, V, times the sum of consecutive integers from 1 to n, where n represents the number of candidates. So just like everything in math, we want to find some way that we can represent the sum of consecutive integers from 1 to n as a formula. And it turns out that we can do that by using n times n plus 1 over 2. And that will give us the sum of n consecutive numbers. So let's find the sum of the first 6 consecutive integers. So if we use our formula, that would be 6 times 6 plus 1, or 7, divided by 2. 6 times 7 is 42, divided by 2 is 21. And if we were to check that, 6 plus 5 plus 4 plus 3 plus 2 plus 1 is in fact 21. So using this part of the formula along with the formula from the previous, we can now write our formula for the total number of Borda count points in an election. V times n plus 1 divided by 2, where V represents the number of voters and n represents the number of candidates. So now let's look at an example, and I'll let you take a few minutes to review those